Hello everyone, today I'm gonna explain to you the concept of direct proof, and then we will go through a very easy question, which is to prove if n is an even number, then 2n is also an even number. And now this is a very basic proof, but to go through the question, the idea is to get you to be more familiar with this concept so you could get to solve more complex proof question in the future. So first of all, let's look at what is direct proof. So direct proof is a proof method where when you try to prove P implies Q, or you could say P implies Q, or you could say if P then Q. When you're trying to prove this logic statement here, the method is always start from the left hand side. So you start from the P, you write out the statement of P on the first line of your proof, okay? And then you do some one or multiple manipulation, okay? And those manipulations have to be mathematically rigid, okay? Make sure you do not make any mistakes in those steps. And then finally, you want to get into a statement, let's call it Q in a quotation mark or Q. Okay, what does that mean? That means you want to get to a statement Q in quotation mark, which is good enough to tell you that this implies Q, okay? Or you could get to the statement Q itself. So this whole thing would be the proof, okay? So general idea, start from P, get to Q. Okay, now let's look at the example I mentioned, which is we want to prove if n is even, then 2n is even. Okay, now just a side note, how do we define even? Okay, we have to have even number be defined as 2k, where k is an integer. Okay, this would really help us to start of proving this statement. Okay, now let's start it. We start from P. Okay, sorry, I missed one step. We need to identify P and Q first, but it's very easy and obvious in this case. In this case, P is just n is even. Okay, then Q. What is Q? Q is statement that 2n is even. Okay, now let's follow the step. We start from P. We write out n is even. Okay, so we do n is even. Okay, what does this tell us? This tells us that n could be written in the form n equals 2k. Okay, now remember always to write your correct domain for your for the variable that you just write out. Okay, so it has to be an integer. Okay, if you drop this part, it's not mathematically rigid enough. Okay, just not good enough. And then let's do some more manipulation on this one. There really nothing much more we could do about it. But now, if we go back to the statement where we try to prove, okay, we need to get to 2n. Now, let's get to the 2n part. 2n. Now what? Okay, not that you have n, you read it as 2k, so you can really sub in this 2k to the n here. That gave us 2 bracket 2k. Okay, now in this case it's really obvious, but I'll just explain it so that just not to explain this question itself, but to actually explain the process of this direct proof. Okay, so now we get this 2n equals 2 times 2k. How do we push it further to the statement that 2n is even? So now this statement really covers the 2n part. Now we need to cover the even part. What is the even part? Go back to our side note. Even part is even part means we could write it in the form as 2k, where k is an integer. Oh, we've got it here. 2 times an integer. Okay, we just need some extra explanation to make it mathematically rigid. So we could rename this 2k L. Okay, because this is L, so that we know L is 2k. K is integer, so 2k is integer as well. Oh, sorry, it's not like. Sorry about that. Okay, we don't need that. Where 2k is also an integer that cover the even part, and it tells us that 2n is even, and a nice square to indicate the proof is completed. Okay, now quick review. Direct proof. When we're trying to prove P implies Q, or if P is Q, we start from P and then we do some manipulation based on P to get to a statement where we're pretty sure that Q is correct, or we get to the statement that Q is correct. Okay? Alright, thank you guys.